Okay, guys. A little bit about lesson 2.6. We'll deal with the rest on Monday. Okay? So lesson 2.6 is graphs of rational functions. So going back and talking about graphs, a lot of it is being able to look at an equation and see what it tells us. See what we know based on looking at this graph. Sorry, I happen to be looking at you right at that time, Jane, and now I'm distracted as he's flipping something against his face. And
I tried to pick it up, but it slipped out.
Yeah. Okay, as I said, I happen to be looking at the wrong place at the wrong time. It distracted me. Okay, so a rational function. What does it mean to be rational? If something is rational, it can be expressed in the form of a fraction. Okay, so as you look at this page, you'll see equations that are fractions. So being able to graph those. Your favorite thing, right?
I hate fractions.
So a rational function is written in the form of f of x over g of x, where f of x and g of x are both polynomial functions. Now, we are looking at what this equation can tell us in terms of asymptotes. We're going to talk a little bit about domain. We're going to talk about intercepts, just a little bit about looking at the equation, what it can tell us, and how that affects the graph. So this first example asks us to find the domain of f of x equals 1 over x minus 2. Now, as we talk about finding the domain, I'm going to tag on here using limit notation. Because we're going to talk about our domain, but we're going to use limits to do this. So a little bit more introduction into limits. Now, okay, domain. We've already talked about domain this year, and these rational functions, really. What are your thoughts about the domain of this problem? What about that 2? Emily just knows something to do with the 2. She's not sure what, but she knows it has to do with the 2. I agree. What does it have to do with that 2?
Equal to 0.
Okay, set that denominator equal to 0, right? Because the denominator of a fraction cannot equal 0. So when we start talking about domain, we're going to set the denominator equal to 0. When we set x minus 2 equal to 0, we're going to get x equals 2. And so, yeah, really what that means, because that's the denominator equaling 2, x cannot equal 2. So that's a value that's not in our domain, right? What's going to be on the graph at x equals 2?
A hole.
Not a hole,
Asymptote.
an asymptote, right? If there was an x minus 2 on top, I'd go with the hole. Because there's a factor of x minus 2 only on bottom, there's going to be a vertical asymptote at x equals 2. This is information I've taught this year, yes?
Mm-hmm.
It's coming back to you in pieces. Okay? We keep building with this information in pre-cal. So let's look a little bit at the graph. So I'm going to kind of sketch a little graph in here. We know there's a vertical asymptote at x equals 2, yes? So there's a vertical asymptote there. And you know that without, you know that, right? Without me telling you. Now, what our graph looks like, and I don't necessarily expect you guys to realize this, but we would start at the positive above the x-axis at the right, and then as we approach that asymptote, we're going up. The asymptote would cause us to flip, and we'd start down the negatives, and then we're going to run alongside underneath that x-axis. Okay, and again, I don't expect you to totally draw that graph without my help or, some more information there. But you understand the asymptote part, right? Okay. What we are trying to do is we're going to talk about this in terms of limits. Okay. So I'm going to write the limits on Monday. just because by the time Monday gets here, I'll need to re-explain kind of where we're at. So we're going to be kind of mid-problem here, unfortunately. But when we talk about the domain using limit notation, our domain issue here is 2, right? The rest of the domain here is good. We can use all these x values except at x equals 2. We can't use that x value. So we're going to talk about, as we approach x equals 2 from the right, where is my graph going as I approach x equals 2 from the right? It's going up. What is up represented as? Positive infinity. So we're going to say as the limit as x approaches 2 from the right is going to equal positive infinity. Now, flip sides. Limit as x approaches 2. So as we approach this vertical asymptote, right? As we approach this vertical asymptote from the left, where is my graph going? It's going down, which would be represented by negative infinity. Okay? I'll review that at the beginning of class Monday. Remind me this is where I'm at. And we'll write out the limits. And I'll kind of explain that limits. Because a big part of this homework is writing out the limits. So, but when we have a domain value, we're looking at it as the graph approaches that value from the left and as it approaches it from the right. Okay? Awkward space to stop, but we're going to go with it. Okay? And we'll pick up Monday.